Okay, we have a few more people coming in, but let's go ahead and kick off now. Let's start with introductions. Let me introduce Helene Thibieroz, who I've known for many years, has been coming from California to Austin and is now doing even more work here in the climate tech space. I appreciate the work she's been doing in the green space for many years now, and would like to have her tell you a little bit more about herself. Helene, can you tell us more about yourself and what you're doing today?
Sure. Thank you very much. Pleasure to be there today. So I've been working with Hal in the 10 Capital Network for quite a few years. I was used to live in Austin. My background is technology. So I had a PhD in EE, started working at Motorola, Austin, Texas, for some of you that come from technology, right? Spent 20 years, around 20 years in corporation working on innovation at scale, technology, business cycle management. 7 years ago, created a company called We Grow Green Tech because my intent was to actually really study that space to scale technology in terms of growth and also measurable impact, right, to really make a difference. And during that course, I worked with many startups, many incubator, many ecosystem, many investment firm to kind of scale some of these aspects. So I gained a pretty good understanding of anything from green technology, climate, and the blue economies that I will kind of like discuss, present for you today.
Great, thanks. And shall we introduce our other speakers right now?
Sure.
So we have with us Clovis Matreau. Clovis, can you tell us more about yourself and your background?
Hello, hi everyone. Of course, I'm very happy to be here and to introduce myself. So I'm Clovis Matreau, I'm French too. I have 16 years of experience in the industry in France. I worked as a business manager in software engineering services companies in France for two verticals, automotive first and then space industry. And I decided recently to move to the USA. I'm still in France, but hopefully I will move soon to the USA. And I'm very interested in working for startups and especially the ones dedicated to environment.
Great, thank you. And also on the panel today is Philippe Michon. Philippe, can you tell us more about yourself?
Yeah, good evening. Again, a French, we colonizing Texas today. Sorry for that. I'm an electronic engineer. I worked a lot in the US, in Indianapolis for a lot of years, and working on some medical equipment. And I moved to the plastic industry in 2006, working on biodegradable plastics. And today, with another partner, we created another company that we're going to introduce to you, which is called Eranova, where we try to make a movement for transition in moving from a certain type of plastics to another type of plastics. I'm working as well as an expert in various normalization committees in France and in Europe. And we are really happy to be with you tonight.
I want to thank all three of you for joining us today. And with that, let's go ahead and pass it over to Hélène for the initial presentation, and then we'll take questions from the chat as we go forward. So anybody in the audience has a question, please put those in the chat box and we'll work those into the discussion today as well.
All right. So let me share. Thank you. Thank you very much for this opportunity to share some of the knowledge based on really a lot of time spent working with various startup and innovation and investment firm. So a little bit about myself. I think I just made an introduction, so I'm going to be going quite quick. I come from technology, same thing as Philippe. I come from EE, master and PhD. Worked a ton on understanding technology requirement, how to translate that into business growth and impact. 7 years ago, this is when I decided to switch to green technology. So what I did organically is move from digital technology, which I was very savvy on because I was working in Silicon Valley at that time with one of the major technology corporation, EDA and semiconductors. And then from digital technology, I evolved more into climate, green technology, decarbonization, which I think could be quite interesting with most of you today, because there's a lot of different avenues available, and it's still an area that's quite new and has not fully matured. And during this process, I exerced different roles, consulting services. I worked at different levels with all this company, from being working on science communication, entrepreneur in residence, also work on fundraising, technology scouting. And also the main point is I built a pretty large ecosystem in that space, in the green technology, climate, and decarbonization of, for example, just to show you, right, that's the ecosystem that I built. Of course, right, the 10 Capital Group it's one of the ecosystem that I work with, specifically, on the green technology side. But as you can see, right, a lot of pretty solid incubator in that sense in climate change that I'm being part of. So now just to switch directly to the presentation. Hold on. So I think what I wanted to do today, right? I think Al mentioned that to all of us pretty nicely. It's everybody wants to invest in climate. Everybody wants to have an impact, wants something good for us and future generation. But it's starting to be a little sometimes overwhelming, right? If you look at the general landscape right now, so it was used to be called clean tech. Then it became used green technology. Then a few years ago, more and more, as we get more and more under climate crisis, a new industry, new sectors called climate technology arised. You may have heard, some of you have heard also, like there's a new concept of blue economy. So if you think about the general landscape, like under green technology, you could put potentially waste management, electronic waste. I'm going to talk about it. It's one of the fastest growing market in the waste management. You have land-based bioplastic, advanced material, regenerative, smart agriculture. Climate, of course, is starting to have a huge traction. That includes decarbonization through new technology, right? Could be renewable energy, hydrogen. Lately, you may have heard about the latest discovery on nuclear fusion. All the concept of energy transition as well, which is about retrofitting current infrastructure, and the concept of carbon capture, carbon platform, carbon economy, which I will touch in more details in this presentation. Then the last one, which I think is really interesting because it's starting to really grow, represent a very large interest in terms of innovation. If you look, for example, innovation in that space, it's really interesting. If you look at some of those financial reports, 2 or 3 years ago, that was mostly, right, renewable energy. Then hydrogen start to come in. And now you're starting to see a huge amount of investment into climate, blue economy. Seaweed, especially, is starting to get a very big presence, looking at where we are today, the harsh realities that we're facing with our climate and our natural resources. So one thing that is interesting is, having been in Silicon Valley, a lot of initiatives that have been driven from Silicon Valley have been on the digital technology side, either linked to IoT, sensors, big data, blockchain. But what we're seeing more and more is the emergence of technologies that I call nature-based technology, natural bioscience, that's based on chemistry, biomimicry, if you like. In the last 5 years, there is more and more solutions that are arising from observing nature. So for some of you that don't know exactly what biomimicry is, it's the observation of nature leading to technique, solution, material that are derived from the way nature is actually proceeding. What's interesting about biomimicry is not every solution is going to be viable in terms of business solution, but because it tends to be associated with circularity and better usage of natural resource, in terms of economic growth and what we're going to see in the next 5 to 10 years, it presents a very interesting aspect. And the last one that I'm going to touch later on today is circularity in terms of innovation and investment is starting to be more and more prevalent as we are entering an era where natural capital, natural resources is going to start to be more and more challenging. The concept of circularity is a concept quickly emerging, both in innovation and in investment as well. So now if we jumped into climate, right? So the climate crisis right now is fostering very large amount of innovation and opportunities. So to give you an example, right, of CO2 metrics, all of our industries, right, whereas it's private mobility, commercial transport, industrial application, marine transportation, generator, aviation, all of it represents a very large amount of emission that are contributing to climate change. If you think some of it, right, like there is some low-level application, generators is an interesting one, right, because generator is used all over the world, sometimes as a backup for renewable energy. So there is like very quickly innovation that is happening for all of these industries, whereas it's electrification or looking at a technology to make the industry more efficient. So opportunity to innovate and invest in that space. All of you, I'm sure, you know, I've seen the increase in renewable energy. More recently, hydrogen, a lot of investment. So as I mentioned, 3-4 years ago, there was mostly renewable energy, solar and wind. Then you see an increased amount of investment into hydrogen. Recently, big announcement of nuclear fusion. Hydrogen, right, as far as of today, if you really start to large corporation investigating hydrogen, there's still a lot of challenges ahead, including, for example, the production of NOx or other toxic element associated with hydrogen, and the other one being the cost, not being at the cost level that will allow full scalability. And the other one, right, associated with specifically renewable energy is investment in what I call infrastructure and energy grid, specifically in the US, right? Like there's a lot of areas, either in the private or government sectors that are pushing for innovation and investment in that space. The concept of decentralized energy is occurring more and more in various places, not only in the US, but also various parts of the world. And of course, energy storage, which has been an area that also have received a large amount of investment. Now, I think what you may have seen, which I think is starting to be quite exciting, in order to fight, to be able for us to reach the climate goal that we have fixed, there's one part which is pushing new innovation. Another part that is capturing the CO2 already existing, and another part which is providing technology to derail the risk associated with this energy transition. When you think, for example, in the context of renewable energy, or even electrification, right? That all these technology are associated with one, for example, common problem that we're going to face is the material used in electronics for these industries. Some of these material are expected to not become sustainable within a few years. That will imply a shortage of some of the electronic equipment that are being needed. There's also a lack of circularity for these industries that has not been addressed. So and then the third aspect is migration, right? How fast are people going to migrate to this type of technology? So sure enough, with this type of concern and understanding that we have only so many years to achieve the goal to reach to reach our climate goal, the concept of energy transition, you can find many funds now that have associated all of the investment that they've done in renewable energy or hydrogen, for example, to the concept of energy transition, looking at technology that will enable us to derail the risk, gain more time to implement this type of innovation, while looking at how to retrofit and optimize current and older exhaust industry. In that regards, one of the companies I will be talking today, Rainlons, that's exactly where they are, using a technology to apply at the exhaust to reduce CO2 and air pollution. The third one, which is in my opinion fascinating, but it's also quite risky at the moment, is a direct carbon capture technology. So what's interesting is, as of today, right, you've seen the most common example in Europe right now is called Climeworks. So you're starting to see an emergence of these solutions that are hardware-based. Challenge with these technologies, they usually require energy to be able to capture the carbon. They usually require large infrastructure, meaning a large amount of investment. And the full net zero, the full carbon capture, like if you look at the full supply chain, it's not necessarily efficient. Like Shell, for example, a few years ago has invested in a direct carbon capture that turned out to produce more CO2 that it captures. So as a result, right, because this place is quite challenging and also you have pro and con as far as if it's the right avenue, there is an emergence of what we call nature-based carbon capture. And I think, for example, if you look at the government and the DOEs, they're actually pushing a good amount of resources in that space. There's quite a few climate funds that are starting to invest to create nature-based carbon, nature-based solution type of fund. And so the advantage, for example, in nature-based carbon capture, so Philippe is going to talk about a bioplastic derived from seaweed. That this aspect is really interesting when you think, for example, seaweed is one of the most efficient way to capture carbon naturally. And so when you're gonna, in the conversation in this presentation later on, I'm gonna be discussing about where we are in terms of natural resources for material. This presents a really interesting avenue because it's not linked to some of the limitation that we're going to see in the next 10 years, for example, of material and supply chain. So all of this innovation are actually being accelerated by what we call a carbon economy. Some of you may already be familiar. I've seen probably some publication on the carbon economy. So innovation in that space go from anywhere to digital technology to accurately measure CO2. So that could be sensors, IoT, satellite imaging, concept of big data as well, because to do carbon trading and carbon credit, you're going to need some platform. And there is a huge amount of Silicon Valley, for example, with the tech crisis right now, a lot of people are actually redirecting their skill and expertise to climate, specifically in this area, carbon platform and digital technology. Digital technology is also expected to improve and increase. As the size of the carbon economy market soar and largely increase, the SEC is going to put more regulation. Initially, right, in some of those carbon markets, there have been some transactions that were not necessarily validated by technology and measurement. So there is some prediction that this area is going to increase quite significantly. So in terms of carbon economy, I just wanted to give you some numbers. So the carbon economy includes various aspects, right? You can see the carbon economy at, for example, large corporations being fined because of some of the pollution that they create or lack of compliance. You have more and more climate, what's called R&D credit as well as grants. You also have more and more tax reduction in place, not only for corporations, but also for investors. I don't know if so many of you knows, but there is more and more clause of being able to deduct some of your investment on a tax standpoint if they linked to a climate action. And the last one, which is I think the one that's been really fueling this economy, is a concept of carbon credit that is quickly expanded. Carbon credit initially was linked to carbon capture, specific application. There's more and more technologies that are being considered, including natural carbon capture resources. So that's going to have a strong repercussion on any type of technology. I think if you look, as of today, in the US, you go from $68 to $75 for a ton of CO2 removed, if you're being qualified as a solution provider. In Europe, it's already at $120. And this is expecting, as you can see, right, the growth of this industry is expecting to explode. A very large carbon credit market with, as I mentioned, probably more and more scrutiny to ensure this carbon credit are being correctly associated. In terms of, so some of you may have seen Inflation Reduction Act. How does it play for climate? So I work with Peter Connors on several projects from the ORIC firm. That's something that in terms of climate that we worked on, right? So the Inflation Reduction Act was really put in place as a legislation to accelerate the transition to a clean energy economy. So what's interesting is initially the Inflation Reduction Act was mostly toward renewable project, starting to get expanded to other areas, for example, carbon sequestration credit, hydrogen. So various industries are being considered. So we're expecting probably that as we push newer and newer innovation with measurable impact, to get the Inflation Reduction Act further customized. Very large amount of money is allocated to this initiative that typically include two types of investment. One being at the infrastructure level, right, when you start a company, and the other one as a production level. So as of today, I think, as I say, what's interesting is it's starting mostly for renewable project, and they start to apply to various industries. So another aspect which I think is also quite interesting in terms of climate and green technology. So we're entering an era where we're bombarded by bad news, really. It's of climate, pollution, depletion of our natural resources. But all of this can be turned into opportunities, right? The climate right now is really being turned into a huge opportunity because of the carbon market being defined, right? By enticing people. If I go back to the previous slides, for example, this one, right? If you think about like there's a slide in Rainlons that show, for example, how much a tanker emit per year, how much a cement factory emit per year, how much, and that's for large application, but the same thing applies for small application. You can really start seeing how the economy that is rewarding people to remove CO2 could really fuel the right type of innovation to address climate. Well, the same thing can potentially apply to accumulated pollution that we have generated, right? Like, so what we're seeing right now in terms of, just to give you a few facts, right? So for example, if you look at the global bioplastic market, this one is really interesting. Right now, the compound annual growth rate is expecting to be around 17%, but that's not taking care, that's not really kind of including the recent dynamic. If you look during the pandemic, the bioplastic production was challenged because during the pandemic, it was all about health, about packaging, about minimizing contamination. So yes, it kind of contributed to an increase of plastic. What's interesting now is the trend that you're seeing, right? Newer generation environment is a first concern. So plastic and bioplastic is an interesting one because you have emergence research and science communication on the whole microplastic is impacting biodiversity and human health, right, through our gut because it's being ingested. So as there's a growing health concern of creating healthy, safer, so leading to kind of more and more company looking at investing in diversifying and trying to kind of in terms of transitioning to a bioplastic that will enable them to address the health issue, address pollution issue, and also attract a lot of the consumers that are more and more concerned by this aspect. There is also a growing amount of regulation, whereas it's plastic ban, it doesn't apply everywhere, right? But it's also, as we're discovering, microplastic is actually contaminating water in a lot of area. There is more and more regulation at a level that is going to impact the plastic production and adoption. Another thing too, which I think is also very interesting, is similarly to where we push carbon credit, right, as a way to kind of enable a climate economy and accelerate and fuel a carbon economy. There is more and more movement to create commodities to address some of these pollution challenges that we have. Air pollution, for example, there is more and more movement to look, for example, at methane, which is a very dangerous gas, NOx. So I think there's probably there's a growing trend, most likely, that's going to go with starting with CO2. We are going to have to see more and more of these pollution challenges, right, being monetized. And air pollution is a huge opportunity. That's 8 trillion. And what's interesting to me is if you look at air pollution, that's the elephant in the room. Every place is getting more and more polluted. We don't necessarily see it, right? That is a gradual even. But places such as India, China, Mexico have already, like in terms of health impact, are already being impacted. So this one is a short to mid-term solution that needs to arise. Huge opportunities. There's more and more solutions that are being driven, some hardware to measure the air pollution, right? Because digital technology is very often associated with getting data, control, optimization. But the real solution in terms of how do we mitigate air pollution is involving more of those natural, nature-based technology and science that I was referring to earlier. Another one so bioplastic is also quite interesting, because if you think about the landscape of bioplastic right now, so I worked in that space for quite a few years with We Grow Green Tech, work with some of the technologies that were land-based, with some very decent, good quality. The problem with a land-based bioplastic is that you're going to require water and land space. And water, the price of water, the availability of water in the next 10 years is going to be questionable. We're going to go from a place where water is at a very low cost, very low commodity, to something that the price is going to be expensive. So those land-based bioplastic may be affected by these dynamics, causing the price to go up, and therefore the competitive aspect of the solution starting to diminish. Another aspect of some of this technology, some of this market is if you look at e-waste, for example. E-waste is also a very interesting problem. We all relying on electronics more and more, right, in an exponential way. I worked in WE. When we selected material to build this beautiful circuit and system, it was never based on the sustainability of the material. It was based on electric characteristics. It was based on thermal characteristics, whatever would make sense to conceive to get to electric to optimal functionment. So now the challenge with that is some of the material used in electronics, as are not going to be available are expected to become rare within 5 to 10 years. So the e-waste management market, I actually think this number is a little low based on the work that I've done in that space, because there's going to be a need to recycle efficiently all those minerals if we want to be able to kind of keep reproducing the electronic industry cycle that we're in with new phone, new laptop, new component, new cars. And this is going to impact pretty strongly anything going from renewable to electric cars, for example, because there's a lot of electronical component in those new industry. So the last part, I think it's like I wanted to bring that piece at the last one, because I think if you're looking at investing, traditionally, when we're looking at investing, we would assume that we have unlimited resources, right? So we can pretty much do whatever we want. Well, that's not really the case anymore, right? Most technology that have been pushed until recently were not circular. We're assuming we can produce as much as we want, and we can have growth that is not framed by anything. Well, if you start looking into some of this estimate, right, there is a very interesting study that was done by the Standard Earthmaster magazine. There is going to be a huge challenges in the incoming decades in identifying sustainable source of minerals. material. You may have seen, for example, there's more and more phases of looking at other type of mineral on asteroids, right? Kind of look with the space tech, kind of try to find this mineral in other places. That's the challenge we're gonna see. So modern electronics are gonna be impacted. Everything that's linked to hardware is gonna be impacted. Another aspect in terms of natural resources is, for example, water. The water that we deem to be unlimited, the price of water is estimated to go up. If you think, for example, the soil also in terms of agriculture, the United Nations has estimated we have 50 to 60 years left of topsoil. So when you start looking into like the challenges that we have with natural resources, naturally, what's I call the natural capital depletion is going to dictate innovation, but also financial growth. There's some assumptions that we're used to make that are not going to be valid anymore. So in terms of investment, you're really going to have to start looking at the circularity of the solution. How much resource am I using? And I think in some aspects, some of the technologies that we both bring today are actually well aligned with this concept of circularity and sustainability. So just to summarize, right, if you look at the shape of climate today, there is large amount of innovation fueled by like in terms of climate, carbon economy, anticipating maybe that other areas that are actually also big environmental challenge will become opportunity, probably through similar mechanism, where a market will be put in place to entice innovation and people to adopt it. Whereas it's like air pollution, plastic, water, right? And the last one is really, I think one thing maybe that you want to kind of, if there is any takeaway out of this presentation, is really to start thinking about investing in climate with a circularity and sustainability mindset, understanding that a lot of the resources that we have today are going to be challenged in the next 5 to 10 years. So thank you for your attention. Any question?
I have several questions, Helene. Thank you for that recap of the current situation. If anybody in the audience has a question, please put that in the chat box and we'll get to that in a moment. I hear a lot about the need for nuclear to augment that of renewables, solar and wind, but almost everything I see is around solar and wind, and I rarely hear about nuclear. Are we investing in nuclear? Are there investment opportunities in nuclear, or is that still not politically correct and we have to wait till it is? What's your take on nuclear?
So I think there's more and more emphasis on nuclear energy. If you look at the Department of Energy, they've pushed several programs. Oak Ridge National Lab is actually also that was tasked by the Department of Energy to push this type of energy. So what they're looking at is smaller reactor. You're perfectly right that there is still a lot of fear in the US on nuclear energy, also of how do we recycle the waste product. But the approach that the US Department of Energy and as well other institutions have chosen is to look into nuclear energy, because that's a way, as of today, that's a very efficient way to produce energy, but with smaller reactor. And you can see more and more fund open to invest. I talked to a few, more and more fund open to invest in that space.
Well, one of the questions I see a lot of is there's many technologies competing, but it's not clear how effective those technologies are. I'll hear from one group that the other group's technology is not as effective as theirs. And I'm wondering if there's any standards or metrics that investors are using to determine it's got to be above this threshold to be effective, dollar per carbon sequestrated. Is there any standards in the industry you see that says the current standard is here, and to make a successful investment, it must be above that? What's your take on that?
So it's a very good question. Until recently, there was no regulation, the carbon market, right? So people were trading, like if you look, for example, there's a large electric automotive corporation that managed to get 2 billion in carbon credit. There were not there was not like a solid assessment because at the end it was not full net zero. So they've been kind of like, because there was not full regulation, the market has been unregulated. Now, as you're seeing more and more in phases, more and more growth in that market, there's going to be more and more regulation. And that's really exciting because until now, you didn't really have very clear metrics on, how much are you really efficiently removing CO2. If you think, for example, I'm being just very purely scientific, you take an electric car. Until we fully resolve some of the problem associated with the mineral in the battery, this is not a full net zero solution. You're creating a full net zero solution where you are, but your supply chain is still producing CO2. So I think what's interesting with the carbon market, the carbon economy, is that you're going to be able to put in place solid metrics. That's going to help investors to invest. That's going to help picking the right type of innovation. For example, like the system example for the direct carbon capture, right? The direct air capture technology. They've been initially a lot of companies pushing very complicated hardware solution. But when you really start to compute all the metrics associated with the capture of CO2, but what it takes, right? The production line, associated with capturing the CO2, then very often become very minimalistic. So I think as you're starting to enter an era where it's about understanding the technology, it's about it getting certified. There is more and more process. Like I'm working right now with this a large environmental group in the US. They have identified a direct air capture solution. They just got it certified, right? You're gonna have to go through the process of getting it certified. And once it's certified, that's actually the de-risking for investors and corporation to be able to, and that's, I think, the concept of carbon platform, right? Because that's the idea, like certifying a technology so that it can get carbon credit when you get scaled, and investors can also kind of have a peaceful mind as far as, yes, I want to support the good technology, good for our future, but it has to work, right?
Okay, well, thank you. And a question from the audience is, whatever happened to wave and tidal power? I know many investors invested in wave solutions several years ago, but I don't see those being talked about anymore. Did those not play out?
So there is one in Texas, in fact, that I get to work on. So the wave and tidal power, it's I think that is why the concept is really interesting, because if you have very strong waves, you could actually you can actually create a huge amount of energy, and the wave is something that, right, it's like it's sustainable, right? It's like the wave is a constant wave. Challenge with that is you're in ocean, right? So it's a very harsh environment, right? So you have the concept of maintenance of the platform. You have the recuperation of the energy that needs to go from offshore to onshore. And then you have to say, when you think about the complexity of the energy grid in the US or anywhere else, how do you distribute this energy and how do you map into what's existing there? And I think most tidal and wave energy have been really successful at proving the concept. But I think the challenge is always like working with energy and utility corporation to be able to kind of put this energy into the grid.
Okay. Well, the concept of taking minerals from space was mentioned a few minutes ago in the context of circularity. Does anyone in the investment community actually consider that to be part of the circular economy? How is that not just continuing to be the extractive economy, but outside of Earth's boundaries?
So I don't know what this gentleman is, but I will totally agree with him. I think it's almost like we depleted our environment, so let's go outside to deplete it even more. I think the mindset should really be about how, right, as a way we could make technologies that we've developed more circular, right? Like find a way to maybe to reduce plastic, to degrade it faster, find a way not to generate pollution on all the infrastructure or reduce it, so that, and then we push newer innovation, and you have kind of the idea is to reach a balance where we can kind of keep evolving. And the idea of always going to get for new thing, it's just not like this that we will be resolving the problem. I think maybe you need that as a workaround, right? Like if we need additional material, it's like water. Do we need desalination to avoid tapping into natural resources on land? Right? But I think the solution is really to create a regenerative circular model with what we have on Earth.
Our next question is, in 0 to 1, Peter Thiel describes the green investing craze of the noughts. It led mainly to crashes and bankruptcies. What is different about the current investment surge? I know in 2010, many people invested, and the number one complaint I heard from investors was the technology did not perform. And that seemed to be, universal. Maybe there are other reasons, but what's your take on how is it different this time?
So first of all, the 0 to 1, Peter's book, is about Silicon Valley. And I think, just to be honest, Silicon Valley has been about large profit, about digital technology, about software, the type of climate innovation that you need today, right? Yes, you're going to need some digital technology to be able to measure, control, monitor, but it's about creating circularity model, about some of the production mode and manufacturing mode that we have created. So I don't, maybe at that point, right, the fact that it's a green investing craze of the North, where they push fast technology without thinking about, is it circular, is it sustainable? That could be well the case, because that tends to be a model aligned with Silicon Valley. But I would think as of today, where we are people, if you think about the solution, for example, Eranova, right, that Philippe is going to be pitching later, this is a very interesting technology because it's pushing a production that's answering customer need, that's not using water, reducing CO2 because that's a natural way to capture carbon. So people these days, I see more and more founders and innovation really thinking as a problem as a whole, not just to make money, but say, we're going to make money, but it's also going to be sustainable. And I think 10 years ago or X years ago, we probably didn't have this kind of mindset of really what's the circularity of it, right? And maybe we're at a different place as well.
Next question is, how are the numbers of electric vehicles constrained by supplies of key elements such as lithium used in batteries? It seems like everyone's focused on the battery and the electric grid, but it seems like those are built on rare earth metals that are in limited supply. Where is that going to come to bear?
So this is really interesting if you think about EV. As of today, because I think initially this innovation was launched to not produce any pollution at the output. They didn't think about all the production line, right? So I think you have an innovation that needs to be refined. Battery is one. Another thing that people don't talk too much about it is, in order for us to build enough charging station to be able to fulfill the entire production of EV, we're never going to have enough copper. As of today, we use copper. We're never going to have enough copper to fulfill this. So 5 years from now, if we don't find a solution for the material that are being used, you're not going to be able to scale and serve the demand. That's why the concept of transition, right, like environmental transition is key, because you can't just put all your investment in one basket. You have to understand we're now entering an era where resources are going to be tight, where you may be able to kind of push one solution in an area and another one kind of create something, for example, where you're going to be working more on the exhaust, reducing the exhaust. So the lithium, for example, they're already realizing they don't have enough lithium. So they're trying to create a circular model around lithium, how to regenerate. There is also new innovation in terms of batteries. They're looking into maybe using water or other type of technology. So eventually, I think it may get addressed, right, as you get smart people working on this innovation. But that's the risk that is inherent to the EV. And I think when we think we have only according to the scientific community, only a certain number of years, I think you want to be kind of open-minded about your strategy and build a portfolio of technologies that are complementary.
One of the technologies I hear about a lot is geothermal, and it's been around for a while. It seems like the technology's improved. I do get investment opportunities every other week now, wanting to use depleted oil wells for geothermal. Not to say that they're near the key populations where you want to supply the power, but what's your take on geothermal?
So it's interesting because I've seen the head of DOE lately really pushing kind of like it's scenarios that they're kind of investigating and pushing. I think everything at the end of the day is about cost and efficiency, right? That's kind of as much as I like a technology, you have to look into, is it feasible for a company to do that, right? What's the cost? And I think the geothermal, on this one, I think I have limited knowledge. What I've seen more and more. If you look at the percentage of interest in the last few years and compared to here, that's definitely increased. But I haven't looked really at the technical aspect of it to see if, from a cost standpoint, if it will make sense. And I don't know if geothermal also will qualify because a lot of it is going to be influenced by regulation. Like, for example, right, if you look at the Inflation Reduction Act or the carbon economy, the legislation needs to allow carbon credit for specific type of solution, right? If they allow only this type of credit or grant or any type of investment for a specific type of technology, then people are going to be more geared toward that direction. And I don't know if geothermal benefits from is part of this program.
Well, I looked at the technology 10 years ago and it was highly complex and it would only work in very large scales. But here today in the eastern side of our county are housing developments that are based on geothermal. And they're all networked together. You just don't build your own, you build it with a network of others. But I get the impression the technology has come down and is much more efficient than it used to be. Iceland is all geothermal. And so it seemed like there's good examples that it can work, and it's not, dependent upon the sun or the wind or renewables that come and go. It's always there in most cases. So I was just curious as to where that was going, because you don't really hear much about that one either.
No, but I think it's also a matter of people awareness, and not every solution is going to work everywhere. I think it's like if you think about wind energy right now, there's been like offshores. There's been a lot of initiative coming from oil and gas to diversify. So some of them, right, have invested in fact, bioplastic, in several technology of bioplastic. Some of them are looking into how could they retrofit the older infrastructure into newer technology. So I think that's depending on where you are, that could be various application. And so I would think everything that's coastal could benefit from wind. The wave and tidal, everything is about if this technology can be included easily, or maybe into like a decentralized grid, right? You could potentially think about doing something at a smaller scale that would be depending on it. But I think if you start to kind of wanting to expand, that's where you're just gonna start to. But the other thing too is the water, for example. I think you're gonna see more and more, call it climate green, but water becoming, like if you look at the price of water in California, it has raised by 30% last year. And Central Texas is going to see a similar dynamic based on the studies that I've done. So you're going to have the price, it's already being resale, sold, and so on. So this is going to be a big problem in the next few years. So I'm expecting that you're going to see a lot of innovation in that space as well.
Okay. Well, on that happy note, let's we're finished with our questions. Appreciate the information so far. I have a high enough water bill already, but now I'm really worried. So let's bring up our next speaker. Let's have Clovis Metro come on and talk about more of this good subject here.
Hi again. Let me share my presentation. Okay, so thank you very much, and let's go to Rainlons. So following what Hélène said, I think I have a good project to present you. Rainlons is the solution to depollute the planet by transforming CO2 into clean air. So what is the problem that we have? We have a very serious problem in the world we live in. It's air pollution that comes from human activities and various industry. But in this pollution, the main one is CO2. So here you can see that we can have two categories, small exhaust systems, but very large volumes of systems like passenger cars, planes, ships, and so on. And second category is large exhaust systems, but smaller volumes. Here we can have power plants, cement and steel industries, and so on. But what we have to see here is the amount of CO2 that is emitted per year. It's billions of tons. It's absolutely huge. And this is the problem we have. But we say we have a problem, but it's also a huge opportunity because, as Hélène said, now carbon has a price. And today it's around $75 a ton, but it could be higher in the future. So here we brought some numbers. It's not important to read all of them, but just to figure out what it means in terms of emission of CO2. For example, a motorcycle is more than 1 ton a year. And if you look on the right side, the large exhaust systems, one big coal power plant is more than 32 million tons a year. So it's a big problem, but it's as well a massive revenue stream if we can exploit this. So at Rainlons, we have a solution for this. This solution is roughly like a pipe segment that you can attach to any exhaust system, new or to retrofit existing exhaust systems. And it's a low-cost system and scalable and easy to implement. So as of today, we can see that as one of the fastest paths to net zero CO2 emissions. It's very adaptable to any system, small ones like motorcycles or car exhaust systems, or big ones, power plant and so on. And it's pretty low cost. So what is our approach, or how does it work? It's based on real science and academic research. Rainlons has designed a system that breaks harmful molecules, such as CO2, into harmless ones by ionization. So we rely on biomimicry, and that is possible with both material science and electrochemistry. So it is implemented in our product thanks to our coating technology and innovating filter design. So the polluted air goes inside, and then it's filtered, it's purified inside our system, and then it goes out like clean air. So the advantages are numerous, but it's low cost because it's quite simple to implement. It's replicable, sustainable. So in one word, we have been able to break a molecule of CO2. And why is it difficult? Because breaking this bond requires a lot of energy. And that's why it's very difficult, and it's a challenge today. And the existing solutions are too expensive to scale and inefficient for exhaust systems. But our disruptive technology is able to do it without any added energy. So it works with ionization, and it works with the heat and pressure that you have already in an exhaust system. And we can prove it because we have already done some prototypes, and those prototypes gave us some very good results. You can see on the left-hand side that at a pretty high temperature, we could reach more than 96% of CO2 reduction and up to 100% of reduction of other pollutants. So these are prototypes. We are still improving the technology to get even better results. We can mention as well that our IP is already protected and we filed 3 patents as of today. So you already saw this slide, Hélène already presented, so I won't repeat everything, but I mentioned carbon as a price. It can bring a lot of money, but we can mention as well that if we help industries to reduce carbon emissions, that will help them to comply to new regulations, for example, or even to survive or last longer. For example, the market of thermal engines car is threatened by this. So if we can help them, maybe it's going to be a transition, but it's very important because we can help them to not pay those taxes and to comply to new regulations that are going to be more and more complex to comply. Then we are currently discussing with partners and big companies. We are working on development agreements for specific prototypes. We are discussing as well on pilot agreements with some corporations we are discussing with. And the idea is to convert organically into full-scale commercial licensing agreements and deployment. Then this is the same presentation, but you can see that we are discussing with major companies like car automotive OEMs and global companies in energy and environment. And we have those deals and in prevision and already started. So we mentioned the revenue just to show that it's major companies across the world. We can present a very quick financial forecast. I won't go to the numbers right now, but what is important to see here is that we see a very high potential for rapid growth because let's say the business model is quite simple. For the first year, let's say 2023, we will work on fixed price project with some partners and customers to develop pilot. And from 2024 onwards, we will start to get royalties from this product. And as I already said, the three most targeted industries are energy, of course, land transportation, automotive, two-wheelers, and so on, and maritime transportation with big tankers and cargos. Then this project is supported by a very skilled and experienced team. All of us have more than 15 years of experience in various areas, such as engineering, business development, science, entrepreneurship, innovations, and so on. And this team will bring this project on the table and help to scale it. And the final slide, this is our ask. We would need $1.5 million as an investment to cover additional R&D activities, because we have prototypes, we have proven the technology, but we have a lot of work to do to improve them, to scale them to different size of systems, to work on patent protection, and of course to give salaries for our core team. The fundings, I mean, the money we already have comes from the founders and company insiders, and with that we have been able to file the first patent and develop the first technology. But we really need to improve that. So thank you very much for helping us to develop our solution, to make it efficient, optimized, scalable, and start saving lives and preserve the future of the planet. Thank you.
Well, thank you for that. We had one question from the audience about intellectual property. Am I correct in assuming you've not filed anything yet? Is that correct?
So
Have you filed any patents yet?
Yeah, we do. We have 3 patents.
Oh, 3 patents. What was filed and when?
So the first one was for direct air capture technology. Second one is for exhaust technology. Third one is mechanism of action. So the 2 last one in the last 2 years, and there is a PCT for Europe that is that has been filed as well, because we have, and we're about to file for 2 other countries because we have interest of commercialization there.
So these are full patents, not provisionals?
Yeah.
Okay, great. Thanks for that.
Thanks,
and then there was a question about, explaining more the formula that you're using in the early part of the presentation for the interaction. So I guess it's more of a feedback question, but did you want to say anything more about the formula itself?
So as of today, a lot of this is covered under NDA. So what we could safely disclose is the fact that and you can see the companies that has performed the measurement. It's a very well-established environmental corporation in the US. Based on this, we've seen an increase in oxygen in the same ratio as a decrease. So we kind of demonstrate that we're breaking the molecule of CO2. The interaction right now, we have identified different avenues. And the funding is actually to go to do some really advanced testing at the molecular level to confirm this finding. But if the gentleman would like more information, more than happy to talk more to him under an NDA.
Great. We'll make an introduction afterwards. With that, I think we'll go ahead and move to our next presenter. Thank you, Clovis. And now we'll have Philippe shown. Come on, Philippe, if you could go ahead and turn on your video and launch your slides.
You're ready to go, sir? Okay, well, I'm showing you the presentation that I'm doing next week in Oslo, in Norway, in front of a panel of investors. So that's not exclusive, this presentation, but you're going to see what I'm going to talk to next week. Basically, you all know we are full of, our generation is full of plastics. Everything is based, fossil-based material. And there is a lot of questions of plastic bashing and how to ban plastic. Plastic is a magic product. And for years, it has been a question about using a bio-based content, what we would call bioplastics. Same as biofuel, since 15 years, we're looking for alternatives to fossil resources. So first is the first generation of biomass, of bioplastic, which is based on food and agricultural land. Here we are talking about soy, palm, corns. Those are using land, and they are in competition with food. This is what we call the first generation. The second generation of biomass is using waste of the agriculture. You can have sugarcane, for example, in Brazil, Braskem, which is endorsed by the petroleum company Petronas, is using sugarcane waste. But this is again using land. Well, we can discuss if it's in competition with food or not, but for sure it's using agricultural land and reaffecting the land to other purposes than the full feeding the people. And now we're talking about the third generation of biomass. The third generation of biomass is basically, it's using bacteria, it's using seaweeds. We call that as well the blue economy. It's not using agricultural land. It's using landscape which cannot be used for food, or it could be as well offshore harvesting. Those third generation of biomass, especially seaweed, which is our main topic here, has got a lot of advantages. First of all, they're fighting against the climate change by preserving arable land. So you're not using pesticide, you're not using fertilizers. Then using those algae, and depending on the business model we have, as if we take Eranova as an example, we are talking about the algae which are polluting the water. You've got them in Gulf of Mexico, Sargassum. We've got them in France with Ulva rigida. And by using those as a resource, you're protecting the sea and fighting against the biodiversity. Then obviously you're going to adapt this usage of this biomass to reduce the dependence on fossil resources. This is going to help you reduce the plastic pollution, and you're going to accelerate the industry transition by moving the transition to an existing model to a new model using renewable resources. So this is exactly what we do with Eranova. We address these 5 topics. Then it has been said there is pressure in Europe and in the US as well. I know it has been some legislation to ban some plastic bag. Some passed, some failed. I know in California, in San Francisco, I know in Texas, it has been some legislation. So there is a clear objective for the new generation and for the brands to go away from the plastics 100% fossil based. So what do we do? Basically, we're going to use those seaweed. Could be several models. In France, we're using the seaweed which are on the beaches, which are resulting of the pollution of the agriculture. So we collect those algae. Why using those algae? Because those algae has got a very high productivity. When you put them in specific raceways, in ponds, they're going to reproduce themselves. It's a plant, but it's as well an organism. So they reproduce themselves, and their productivity, it's about 20 times more efficient than arable land. Then if you use those algae which are on the beaches, you're going to use a pollutant as a resource. It's free of charge, and you are upcycling a pollutant, and you're going to transform that pollutant into resins, which is going to be used by the plastic industry. How do we do that? So we work with municipalities today. It's part of our business, and they bring those algae to our plant. Our plant, it's a very large raceways. Today they are 300 square meters. Sorry, I'm not too good in inches, but well, they are ponds connected to the seawater. When those algae are in the ponds, they're going to reproduce themselves. When they reproduce themselves, they're going to capture CO2. So we have a very strong carbon sink. I'm going to come to numbers later on. We have a patented process on that. And those algae, we are going to stress them. We're going to extract from those algae the starch. The algae, they contain the starch, about 10–12%. And when we put them in the ponds, we're going to stress them. The level of starch is going to increase. We're going to collect the starch on one way and the fiber on the other way. We're going to bleach them because we are going to remove the odor and the color. So we have on one hand fibers, and we have on the other hand starch. That starch, we're going to polymerize it, plasticize it, and mix it with recycled fossil-based plastic or virgin plastics to create these granulates. So on the down of the picture, you can see the process. We go from the green algae, they become a little bit less green because they are stressed. Then we bleach them, then we extract the starch, then we make granulates, and from that granulates, we're going to sell it to the plastic industry to make any type of plastics, which is flexible or rigid material. We go from, I come back there. We go from the bio-based content, we can go from 25% up to 100%. We can make 100% soluble material or compostable. For example, California is very much for compostable product. And we can address most of the application on the plastic industry, which is for thermoforming, for food trays, or it could be for car interiors or cosmetics, all of the applications. So our market, it's 280 billion tons of material. It's a huge amount. The carbon sequestration, it has been presented in early slides. It's a key issue for tomorrow. And when you have a business model which is not only reducing your dependence from fossil resources, improving the life cycle assessment of the product, and as well showing that you can capture carbon, that's a huge benefit. And this is what we are able to do. For example, seaweeds are capturing 10 times more CO2 than forest. It's huge. It's not depending on the season. You have the growing all the year around. And Texas, for example, where you have sun, you have water, then it's ideal to grow seaweeds. So this is basically what our business model is with Eranova. Then another thing of seaweed, it's doing bioremediation. Bioremediation means what? Those raceways that we put our algae on, they are connected to the seawater. If you are on a seawater which is polluted by nitrate and phosphate, the algae naturally are going to depollute the water. They're going to be fed by those pollutants, and the water then you're going to reject into the sea is going to be cleaner than the one that you're going to enter. So if you add all of those things that I've said, you are depolluting the beaches if you have algae on the beaches. Then by harvesting, you are capturing CO2. Then by stressing them, you are depolluting the water. And by creating that new generation of bioplastics, you creating a decarbonized material, which is going to be a very nice replacement for the existing fossil-based plastics. Where are we now? I mean, we've got several awards, a lot of awards in Europe, not in the US yet, because actually this is the first presentation I do in the US. We are on the market with a large supermarket in France, Carrefour, Intermarché. I'm sure some of you know those names. We started by low-tech product, which is giving us some volumes. We are limited today on our volumes because of the size of our plant. And this is why I'm talking to you, and I'm going to explain to you later on why. So today we can replace the plastic, as I said, for garbage bag, for cups, for car interiors, for e-commerce envelope. We are starting to work in Europe with some e-commerce for retail market, for packaging. I mean, all of the plastic application that you know, we can come in and be a disruptive solution. Where are we today? We started in 2016. We are two founders, very young founders. We have done a small plant in 2016. We have built another plant in 2020 where we raised 6 million euros, about 1.3 hectares. We're producing about 300 tons of product. Now we are funding our scale up to be able to do 30,000 tons of bioplastics. We're raising 60 million euros. We are financed by the French government, 17 million, by the European Bank of Investment, 30 million, and we are working with funds for private equity. Looking today between 15 and 20 million. We have sold a license. Our business model is make a plant in France. We are making up another plant in Morocco. We have signed a license in Indonesia, and we are just going up for, as I said, for the scale up. This what would look a plant in Texas. You know, this picture has been done by artificial intelligence, you know, the software DAL, you know, so it's not real, but I thought it was fun. We are a small team. We are 10 people in France, working with a high-level R&D company. The capex for building a 30,000 tons bioplastic plant is about 60 million euros, 58 million, about $62 million, with 30 million on a lot of construction in ponds. Today, as I said, we found money with the French government, with the BI, and we're looking for private equity. We're working with EY. Today, we've sold a license in Indonesia, and it's going to start end of the year. Our business model is based on royalties and licensing or JV. Again, Texas is a potential very good candidate for the land which is available, for the sea, for the sun. And again, the market is unlimited for us. And it's already happening for us. I'm going to show you a little visit of, here you are in south of France, close to Marseille. We are in an area with a lot of industrial petrochemical company. This is the ponds I'm talking to you about. So in this little place here, the algae are coming in. We clean them with a kind of with air pressure. Then we put them into the raceways, which are here. Those are small. The objective for the scale up is to do raceway which are 10 times more bigger than this. Those are the raceway where we do the bleaching. Again, no chemical at all. Okay, you know, it's really an area where there is nothing else. So we have support from the French government because we're creating as well a new type of employment, new type of economy. Very simple technology, but again, patented. This is specific, I don't know the word in English, but well, okay. Well, this is where we collect the algae. We remove some of the water. Then we make them, we bleach them. We're going to show you that. I won't show you the process because it's patented, but you know, we have this is our what we call photobioreactors, where we make some testing to improve the yield, improve the level of growth of starch in the algae. And this is where we make the compounding. What I mean by compounding, it's this is like big spaghettis, which are then cut into little. Sorry. Sorry. We're not going to do two. Yeah, this is large spaghettis, which are then cut into little granulates, and those granulates are exactly the same as what the plastic industry is using. So you have no change in the machinery, and it's a very, very smooth transition to be able to make a bio-based material in complement to existing fossil-based plastics. So this is really a clean summary, and I know you understand all of it. Reduce the dependence on fossil resources, protect the biodiversity, accelerating the industry transition, cleaning the algae if you have pollution, and capturing CO2. This is really what we're doing. We are labeled as well by an organization which is a Solar Impulse. I'm not sure you're familiar with that, but and labeled as one of the best 1,000 solution for saving the planet tomorrow. Thank you, sir.
Great. We have a few questions for you at the end of our time here. First question is, you have those little algae-based plastic or algae-based capsules. How do they compare in cost to build to just general plastic?
Well, the product we sell, we are very competitive. As you know, we're doing garbage bags. So garbage bag, you can't be 10 times the price of a normal garbage bag. Otherwise, nobody will buy it. So today we are about 10% higher on the finished product than a normal fossil-based resins.
It seems unusual given the amount of infrastructure it takes to grow and capture algae and process it compared to plastic. It just seems that it would be a lot more expensive than 10%. Are you sure it's only 10% given the cost to build all those facilities there?
Yeah, because really the raw material is no cost. The raw material is no cost. Really, you're not using any pesticide, any fertilizers. You're only doing the raceway that you have seen are concrete. The one that we do on the scale up are not in concrete. You just draw, sorry, I don't know the word in English. You just draw stuff in the sand, you know, or in the soil. You put a liner. You're not doing concrete. It's too expensive. It would be too expensive for large scale. On a scale up, it would be really in the ground with a liner and a circulation of water. You can use solar energy, you know, especially in a area like Texas or Arizona or whatever. We're not using it yet in France because again, it's a pilot plant.
Okay. All right, very good. And how much government funding do you need to install a plant around the world? How much money would you have to put in just to establish the plant?
Well, usually, as I said, it's based really today at the European cost, $60 million give you a plant of 30,000 tons of bioplastic, which is going to give you a turnover of 90 million euro with a profitability of 22% net profit.
Okay, great. Well, I think that's it for the questions. We'll share your contact details with the audience and hope to make further connections with it. We do have the recording we'll share with those who did not make it today as well. But thank you, Philippe, for your presentation, and you as well, Clovis and Helene. Thanks so much for your information. It's very informative and I think it's quite fascinating, and we're going to be having more of these discussions going forward. Thank you for sharing your information with us today. With that, we'll go ahead and wrap up, and we'll hope to see you again in an upcoming session.
Thank you.
Our pleasure.
Thank you for the opportunity. Bye, everyone.
Thank you very, very much.